Welcome, good people. We got some science today. We're doing every element ever. Today we got an interesting element, probably not the most famous element on the periodic table, but it is an element nonetheless, and we're going to learn about it. Here we go. Time for science. So, we got beryllium here. Beryllium is element number 4 on the periodic table. Probably never heard of this element, although it is a really cool metal. It's very shiny and brittle, and it's kind of silvery white. It's also very strong, which we'll dive into shortly as well. I have a really cool box here for us so we can see where it exists on the table. And its atomic mass is 9.01 atomic mass units. That's what scientists use to measure the weight of this thing. It is very lightweight, only it's got 4 protons, 4 neutrons, as we know. And over here I have that it is in period 2 in the periodic table and in group 2 of the periodic table. So how about that? 2 and 2. And it is element number 4. So pretty cool. So I also have here, has a super high melting point. We're actually going to dive into, it is the first of, I'll go ahead and dive in first here. It is the first of the alkali earth, capitalize earth here, is the first of the alkali earth metals. What does that mean? Well, all these metals have similar configurations of electrons, which we'll jump into very shortly. Just like electrons jumping around, we're going to jump to that too. So all these, the second column here, are all alkali earth metals. And we're going to learn into what makes them an alkali earth metal. And beryllium here, one of the most fascinating things that I learned about this, I want to share this bit of amazing knowledge here. It is found in emeralds. How about that? Pretty amazing. It is found in emeralds, which are known as beryl minerals. Or I should say emeralds here are more gemstones, so think of like the shiny, beautiful green gemstones that you guys know of. Emeralds are actually a type of mineral called beryl, and the blue-green ones are, in fact, emeralds. So we're going to learn about its discovery too, but this is actually one of the ways in which it was discovered. It was actually extracted from these beryl minerals, and some of them were actually emeralds. These alkali earth metals, they actually have something in common. They have a very unique feature about them. The interesting thing about alkali earth metals is, in the case of beryllium, beryllium has 2 s orbitals in its form, in its fancy-dancy science atomic shape. So it has these cool s orbitals. Scientists, because they like to confuse people as they do, as brilliant as scientists are, beryllium actually has 2 s orbitals. So here, these 2 are called orbitals. It's kind of like a planet. Remember, planets go in orbits, but in the case of atomic physics, scientists like to call it orbitals because they like to distinguish between a planet and an electron. Because an electron, in fact, goes in kind of like, it doesn't exactly follow a circular path, so they call it orbitals. Anyway, just know now they call it orbitals, but it has 2 of these guys, and they call those s orbitals. Well, these s orbitals, because there's 2 electrons in the last ring and the last orbital of beryllium here, because there's 2 in that last ring, this makes this atomic nucleus very super stable and not very reactive. Unlike lithium, unlike the alkali metals just to the left on the periodic table. So if we jump back to the left over there and we crawl on back over there, we check out our alkali metals. But beryllium, not so reactive because it has a grip on these 2 electrons. These electrons don't really want to jump. They don't really want to move. It's solid, bro. It's like, I'm good, I'm going to hang on right here. Now, it still reacts with some things, and it's not the most stable element by any stretch, but they're just much more stable than the alkali metals. So I like to think of the alkali earth metals are more grounded. How about that? It's more like ground-type Pokemon. They're more grounded. They're like Diglett or something. Like, they're in the dirt, they're in the ground, they're more solid. They're like, I'm good, I'm not going to give up too much stuff. So they're in the earth, they're more solid, they're more grounded. It does oxidize a little bit, so it does react a little bit with oxygen, just a little bit. And it does have some other reactions, especially in like nuclear physics and stuff. It does have some other reactions that it can react with. How about that? Other chemicals, other elements. But it is not that reactive. When it does react with those elements, it is a little bit slower, and it doesn't like burst into flames, kind of like lithium, and it doesn't like explode. It's not a very energetic release of the element because it doesn't want to pick up these electrons very quickly. It's actually 6 times more stiff than steel. That's right, 6 times stiffer than steel. So it's actually even stiffer. I don't believe it's stronger, but it is way stiffer. It actually doesn't want to bend very easily. It can bend, but if you bend it, it can be very brittle. So it still kind of breaks apart, and it can be like a powdery. Sometimes if you can grind it up, it can be very powdery, but it is super, super stiff. So because beryllium here is so great and it's such a strong, durable material and lightweight, they actually use it as the mirrors for the James Webb Space Telescope. So all those fancy mirrors that the scientists had to polish and make perfect and everything, they put a little gold coat on it because gold is great at reflecting the color red. How about that? Fun factoid there for you. But they put a thin film of gold on top, but the actual mirrors were actually made out of beryllium. Isn't that crazy? I didn't even know that. It's actually made out of beryllium, and they polish these things. I had this video of this scientist polishing these beryllium mirrors. So all the amazing images that James Webb is bringing to us now and kind of giving us this new idea of galaxies in the universe, the early universe after the Big Bang. All these amazing images of galaxies, the deep field images, even more beautiful than Hubble, if you can believe that, using infrared. Just amazing stuff, but that is all thanks to our boy Beryllium here. How about that? I didn't even know that. Now you just learned something. A couple other things that's really good use for is it also does this thing called neutron scattering. So it's used in nuclear reactors, nuclear power plants, because it's actually really good with bouncing off other neutrons. So when other neutrons come flying in, like let's say here's like a neutron that's like super neutral, it's like flying in, and because of it's just the feature of beryllium that these 4 protons and the 4 neutrons in its base form. I don't know if they use isotopes of beryllium, but this configuration of beryllium, it actually bounces off a lot of neutrons, excuse me. So the crazy thing about beryllium, like for some reason it's just really good at deflecting neutrons and it bounces them around. Another thing that can happen is sometimes the neutrons, if they move fast enough, they can actually break apart pieces of beryllium. In the smashing of neutrons, new neutrons will actually be generated and actually creates more neutrons. So that can also happen. So beryllium being the weirdo that it is, it can actually generate more neutrons or it can bounce them back. And our discoverer of beryllium, our final point here, our discoverer in 1798, he was a French dude. This guy's name was Nicolas Louis Vauquelin, or Vauquelin, I don't know how to say his name. French, I'm not very, I am not fluent in French, as it were. But anyway, he found it in a mineral, and this Alkaline guy, this French chemist, he actually found it in a mineral, and he discovered it, but he did not separate it out. So he was a chemist, but he noticed this new element, and he actually saw it with some other elements in this barrel. Do a barrel roll.
A barrel roll.
In this barrel mineral, so he found it there, and actually there's a great story. So he was actually able to extract it, and he got like the powder of beryllium out. But the beryllium was mixed with other things. But back in the day, way back in 1798, right at the turn of the 19th century, so in the late 18th century, nearly 1800, back in the day, chemists, they would actually smell and taste some of these elements. We shouldn't really be doing that anymore because as it turns out, beryllium is actually toxic. He tasted this element and this barrel or beryllium, he noticed it was really sweet. So he's like, oh, that's real sweet. And so his first initial name for it, he named it after the Greek word for meaning sweet. He actually named it glucinim, which was Greek for something sweet, sweet tasting, because he noticed it tasted very sweet. It tasted like sugar almost. I just love that story because he was tasting this sweet yet toxic element. Fortunately, Mr. Vauquelin here, our chemist, was not harmed or anything. He probably didn't, taste it too much, but remember in our science labs, we ain't gonna taste anything, okay, folks? That's just not a very wise course of action. But he was the first one to discover it. It was, of course, later renamed into beryllium, the wonderful element that we have here today that we know. And beryl here, or beryl, actually means kind of like blue-green because it was often found with emeralds here. So it actually means kind of blue-green. It's actually the name of beryl, or beryl. But yeah, I love that funny story of him just tasting this element, this strange element. Like, oh, this thing came from some rocks or something and gemstones. I'm gonna put it in my mouth. We don't want to do that in science. we learned a little bit something back in the day of a chemist, so you don't want to be tasting this kind of stuff. But he was the first one to discover it, but he did not separate out. There were actually a couple other chemists about 30 years after Alkaline actually discovered it. They actually separated it out, and they actually, soon after, they actually, I don't know if they named it, but soon after, scientists actually renamed it once they extracted this material out, the element out, beryllium, and they renamed it blue-green. How about that? The wonderful element beryllium. There we go. Some more science for you today about our wonderful element, the first of the alkali earth metals. It's grounded, it's not super reactive, it's used in the space industry, it's used in satellites everywhere, the James Webb Telescope. How about that? So there you go for our wonderful beryllium today. Elements number 4 on the periodic table, group 2, period 2 on our periodic table. And I'll see you guys all next time for some more elements and more crazy science. Peace.